Welcome back to Initiatives Math class. Today our question is on factorial. That is, if n plus 1 factorial plus n squared multiplied by n minus 1 factorial is equal to an plus b n factorial. Find the value of a. There are two important concepts that we need to understand. The first thing to understand is, for instance, if I have 3x plus 4 is equal to ax plus b, I should be able to compare the coefficients. By comparing, I have a here to be equal to 3. That is, a is equal to 3. And the constant b here, it's 4. That is, b is equal to 4. The next thing is to understand n factorial. N factorial here means n minus 1, n minus 2. That is, it will reduce successively till it gets to 1. And that is the meaning of factorial, n factorial. So let's apply these two concepts in solving this particular question. Again, one also needs to understand that if I have, for instance, 2x plus 4 is equal to 8. If I have an equation like this, 2 is common through these equations. So I can cancel 2 out, and now I'll be left with x plus 2 is equal to 4. Why? Because 2 is common throughout this equation. So let's apply these principles in solving our question here. Okay, so the question is n plus 1 factorial plus n squared n minus 1 factorial is equal to an plus b multiplied by n factorial. My focus for now is to cancel n factorial out throughout the equation. So I have n factorial here. I need to get n factorial here. I also need to get n factorial here. So once I have n factorial, I will not worry myself over here. But I can generate n factorial here. That is n plus 1 multiplying n factorial. That is, when this n plus 1 reduces by 1, I will get n factorial plus n squared n minus 1 factorial. Then I will introduce my n factorial here divided by n factorial. I have not changed anything. If I cancel n factorial by n factorial, I will still go back to my original expression here. So I've actually not caused any change. But because I want to get n factorial, I introduce it here. And then I will get an plus b and factorial. So, like I stated over here, 2 is common throughout the equations here. N factorial is common throughout the 3 expressions here. So I can cancel them out. And that will give me n plus 1, n factorial, no, the n factorial will vanish, plus this n factorial will also vanish. So I have n squared n minus 1 factorial all divided by n factorial, which is equal to an plus b, because this n factorial has also vanished because of the cancellation. And so therefore I'll be having n plus 1 here plus n squared n minus 1 factorial all divided by. Now, I want to cancel the n minus 1 factorial. So this n factorial, since it will be reducing by 1, it will be n minus 1 factorial. N factorial is the same as this. And so this n minus 1 factorial will cancel this n minus 1 factorial. And on the right hand side, I will maintain my an plus b. Now, you can see clearly that I have n squared here and then n here. This n will cancel this n squared and I will be left with only n here. The expression now reduces to n plus 1 plus n is equal to an plus b. N plus 1 plus n is the same as 2n plus 1 is equal to an plus b. So with this, I can compare coefficients like we started. If I have 2n plus 1 is equal to an plus b, my a here becomes 2. Since a is the coefficient of n, 2 is also the coefficient of n over here. And so finally we get the value of a to be equal to 2. So that brings us to the end of this solution. Thank you so much for following Initiative Math class. Thank you. Bye-bye.